So today we are going to be covering solving rational equations. So remember the natural numbers you learned in kindergarten. Sometimes they were referred to the counting numbers 1, 2, 3. Integers now include 0 and all the opposites of the natural numbers. Rational numbers are when you are dividing two integers, you get a fraction, but I want you to notice integers. So not like square root 2 over 2 or pi over 2. Those are not considered rational. Here's a little history lesson. More than 4,000 years ago, the Babylonians worked with numbers that represented fractional quantities. Several hundred years later, the Egyptians worked with what are known as Egyptian fractions. It wasn't until 1,000 years later that the Greeks finally developed, through ratios, the modern day understanding of rational numbers. So a real quick refresher here. An expression has no equal sign, and the goal is to simplify. A legal mathematical move is you can multiply or divide the numerator and denominator by the same thing. An equation has an equal sign, and the goal is to solve for the variable. Legal mathematical moves are balance it out. What you do to one side, you have to do to the other side. So this is really, really important. You understand the difference. All right, so here's the steps for solving a rational equation. I would add maybe a step 0 and factor each denominator first. Okay, let's add that in. Factor each denominator, and then you can easily determine the domain restrictions from that, okay? Then you eliminate fractions by multiplying both sides of the equation by the least common multiple, or least common denominator. Move everything to one side, combine fractions, and then if you have a graphing calculator, so these are different methods, okay? So all of them you do need to do the domain restrictions. So let's just go ahead and start working on these. And number 1, can you tell this one is a proportion? So I'm still going to start by my domain restrictions. You look at the denominators. X could not be -2 and x cannot be -1/3 because I would be dividing by 0. So what you're going to do is the LCD is x plus 2 times 3x plus 1. So what I read above is when you have an equation, I can keep things balanced by multiplying both sides by the common denominator. So maybe I'll write the LCD here is x plus 2, 3x plus 1. So now I can cancel those common factors, and I get 3 times 3x plus 1 and 2x times x plus 2. And I'd like you to stop and think a moment. Look at those diagonals and look at my current statement. This is why multiply by the diagonals works, okay? In case you didn't realize that. All right, now we should be able to distribute on both sides of the equation. And then, lo and behold, I'm getting a quadratic equation. This one is going to factor nicely. So I'm getting x is -1/2 and x is 3. I personally check my domain restrictions. After I check, then I circle or box my answers. All right, number 2. Check my domain, my LCD. I only have one denominator. So what's going to happen is I am going to go through and multiply everything by the LCD. What I like to do here is put that x over 1 so that I don't think it's x over x. So that's x squared plus 5 equals 6x. Well, it's a good thing in Algebra 2 you really learned how to factor. So I'm going to factor. I get x is 5 or x is 1. Go double check your restrictions, and that's okay. All right, so now I'm going to look at my denominators. X cannot be -1 or 2. My LCD is x plus 1, x minus 2. So what I'm going to do, and I personally don't write this out, but because this is my introduction, I'm going to go ahead and show it. You are balancing the equation as stated above, and you have to multiply both sides of the equation. When I say both sides, that's everything on the left and everything on the right. So now I'm going to cancel the x plus 1s. Nothing cancels on the right side. So I strongly recommend that you write down, take a moment, otherwise you might make a sign error. And then I'm going to go ahead and multiply this out. So that's going to give me 5x minus 10 minus 7x minus 7. And at any point, if I'm going too quickly, just pause the video. You have the power. This is a recording. So now I'm going to move everything onto one side. This does factor nicely. So I'm getting x is 1/4 and x is 1/2. I'm going to go back up, look at my domain restrictions, and that one is lovely. All right, now number 4. This one's going to be a bit of a doozy here, okay? I personally like to factor my denominators. And do you notice the second denominator, it's in the wrong order? So I'm going to first switch this, but pull the negative out. Hopefully that'll make sense. I just switched the order and pulled a negative out. So now I can see that the domain restrictions are still 5 and 2. I'm going to do one more thing before I identify the LCD. I'm going to pull that negative out in front of the fraction. So now my LCD is x minus 5 times x minus 2. Now what I'm wondering is, can you go here with me? I'm going to try and skip a step now. I'm going to mentally multiply. So if I mentally multiply, the x minus 5, x minus 2 cancels. The x minus 5 cancels, but the x minus 2 does not. It's just a whole lot less to write out. All right, then this is similar to something we did the other day when we were working on the operations. If you subtract a product, you have to complete the product and then subtract. Think about PEMDAS. Think about your order of operations. All right, so now, I am doing a lot of algebra here. So I'm going to multitask here because I'm running out of space. I'm going to add the 2x squared. I'm going to subtract the 14x, so that's a minus 8x. Now on the left side, I'd have negative 5, but I'm going to add the 20. So that'll be plus 15. All right, so now this is my first interesting answer. So I know it seemed like, well, we don't really need to check our answers, when in fact we really do need to check our answers. So x cannot be 5. So what I do is I cross that one out, and this is why I'm emphasizing you want to box your answers, because that indicates you really, really did check it. All right, then I'd recommend you pause the video and try number 5 on your own, because I think you can do this now. All right, hopefully you paused. And I like to start by factoring my denominators. So then my domain restrictions are x cannot be negative 2 or negative 5. The LCD is x plus 2 times x minus 5. Now, if you look directly above at number 3, I am literally multiplying all 3 parts by x plus 2 times x minus 5. Now I'm going to try and shorten that work, okay? So the x plus 2 would cancel here, the x plus 5 would cancel. On the right side, both factors cancel. Yay, I didn't get a quadratic this time. So notice that. Sometimes you get quadratics, sometimes you don't. So I'm getting 7x plus 23 is 9. Subtracting, I get x is negative 2. Now, when you go and check the domain restriction, that's not an option. So you cross this out, and that means there is no solution. That means there is no number, no real number for x that I can find that would make the left side of the equation equal the right side of the equation. All right, then number 6, I'm immediately going to start factoring. So x cannot be 0 and x cannot be 1/2. So my LCD is x times 2x minus 1. If you thought about the first fraction, canceling the x, the problem is you'd have to rebuild it because it's part of your LCD. So I'm going to go ahead and multiply by the LCD. Hopefully that makes sense what's happening there. So I'm going to subtract 2x from both sides of the equation and add 1. That happens to be a perfect square trinomial, or you can do 2x minus 1, 2x minus 1. Again, that's not part of my domain, so it's no solution. All right, there you go.